Hi everyone, my name is Binu Kohli and I'm product manager at Tiger Graph. I'm so excited to speak here at an event which is one of my favorite data science conferences. And I think early on when this conference started and how it has come in this last 6, 7 years is amazing. And I think I have seen how we have more and more women now in data science who've been contributed and doing amazing things in this for data science. And also, I really want to thank the organizers because I think how this conference has like events, it has broadcast, it has datathons and workshops, which I think help to also learn the technology better. So today I'm going to also talk about one of the important topics which I'm personally very passionate about is solving the data Gordian knot with 360 data. So we talk about all the time about customer 360, patient 360, health 360. Then also in our generation, data is so important. So I think having a 360 view of your data and uh, being data scientist or dealing with the data, you all know how important data is. So I think having a 360 view of your data is so important for any kind of organization or any kind of work we are doing. So here I'll just share my screen and go ahead with my presentation. So it's solving the data Gordian knot with 360 data. So let's talk about Graph, because I just said I work for Tiger Graph, and Graph is so important. I'm personally very passionate about Graph technologies and how we have a different way to look at data. Today is how we look at connected data and how these relationships and how these data connections help you do amazing things, be it in AI, be it in health, be it in, as I said, customer 360, patient 360. Everywhere, Graph is just getting more and more popular and is just helping us answer those questions ever which we didn't even think were possible to ask. So if you have a graph database and if your data is graphically represented, you can ask questions, you can do things which were not possible with the relational setup. So I just brought this quote from Gartner, one of the top 10 reports from 2021. By 2025, graph technologies will be used in 80% of data and analytics innovations, up from 10% in 2021, facilitating rapid decision making across the enterprise. So Graph just kept getting popular and popular. Here also at Tiger Graph, we are doing so many Graph for so many Fortune 500 companies and solving amazing problems in fraud, in supply chain, in retail. And when I look at those problems, it's amazing, right? How we can do now multiple hops in the data. We can look at the connected data. We can look at the relationships and answer questions which we would not have imagined 5 or 6 years back. So I think this a quote by Mark Baer is a distinguished VP analyst. So I think I really like this quote. So I put it in my presentation. To graph or not to graph, that is not even the question. You will graph. So it's just the matter of when you will graph or how you will do it, but you will graph because graph is so important. And today, the use case I'm bringing up about the data also does wonders if you are on a graph database. So let's talk about the evolution of databases. So I have been at Oracle for 11 years and have been really fond of relational databases as well because I think relational databases were the ones with which we solve the problem of transactional or computational problem, right? Because with rigid schema, high performance on transaction, it they just changed the whole world. We were able to solve all the problems where you needed a rigid schema, and where relational databases were not so good, or where they faced a problem or a barrier, was the deep link analysis. The problem where your schema would change very often, and the performance would not be as um, so there would be a poor performance basically for the deep link analysis. But in databases, if you want to solve a connected problem, there would be a foreign key, primary key concept. You'll create a join from one table to another, and you'll fetch the data. And then, when you have like a multi-hop, you have 8 or 10 hops, you have too much connected data. Things are not even possible with a join. So then we move to the key value databases. Key value databases would be, you have a, like my picture here shows, you have a product, and then you have some name for it or a value for it. So it's basically, you have a key, maybe customer, and then you have some value, and then you'll fetch results based on that. So it's highly fluid schema, or I would call no schema. There's high performance if you have simple transactions, and poor performance if you have deep link analysis again. So key value is a type of NoSQL database, or a NoSQL database have existed since 1960. And when Web 2.0 was coming, and companies like Facebook, Google, Amazon grew rapidly, they needed a flexible way to store the data with increasing number of attributes or fields to model customer behavior. And that's when key value database came in handy. So, and then on my right side, we have a graph database. And graph database, I think the first two generations had the same problem like the key value databases. But with Tiger Graph, we solved the problem of um, scale. We have massive parallel processing. We have you can change data too often. You have a simultaneously, you can fetch real-time data. And I think the most important with graph databases, how your data is linked, how your data is presented, how your data has the information, the important information which you need when you are asking a question. So let's look at this example, which I put on the right hand side. You have an order, you have payment, you have customer, then you have location where that order is shipped. And then you maybe have multiple locations, and then you have multiple, and then you might have multiple products, or you have a supplier. So then a customer purchases an order, and then it's shipped to a certain location, and then in between there is so much stuff happening. Customer makes a payment, the supplier gets notified, the order is shipped from some place, is purchased, the product has a relationship purchased with the order. So all these entities are connected, and all these entities has relationship. And those relationships are important if you are analyzing your data as a data scientist. You're giving your data to a machine learning or an AI expert to make a right call, or to have create analytic reports, or generate some reports out of this data. All of these data links and relationships are important, and would eventually help to answer some questions. And it's so important to retain that data when you are dealing with data. So another thing I think with graph databases is there is a flexible schema. There's a high performance for complex transaction, and high performance for deep link analysis. And if you are doing a deep link analysis, even So you can do like basically multiple 5 to 10 level hops on billions of nodes. And if your database is scalable, has parallel processing, and is performant, then you can actually do it real time and very fast for your user. So the question is like, why graph analytics? Graph analytics is a set of analytics technique that allow for the exploration of relationship between entities of interest. In my previous example, I showed the shipped order example, but then again, for any organization, people, or any kind of transaction. If I'm making a transaction, like let's take an example that I buy something from X, some store X, right? And the and my friend also buys something from X. We have a relationship that which is a vertex in the graph, that okay, Binu and this another friend likes to shop at that store, and then maybe we like to eat at some place, or we want to shop together or walk around on a hike at some place. And that basically tells you a story. That so every graph is actually telling you a story, and every node and any vertex that it's containing some information that is very important to make any decisions. If I'm doing a customer 360, I need to know my customer better. I'm doing patient 360, I need to know my patient better, where have been my how my patient has been doing in the past, where does he eat, where does he what is his medical history, how does he how did he which kind of medicines he ate, or other patients doing the same things, and then connecting those data and creating relationships and making better decisions on the connected data. So then um, so I want to briefly talk about some of the use cases which I've seen being a product manager at TigerGraph, and I think are really critical, really important, and I think Graph does amazing job in solving that. So I think one of the important thing is that distributed graph DB helps you connect all the data sets and pipelines. So there is a customer 360, which can connect all the data sets and pipelines, having all information about your customer. So we did a use case for United Health Group, where we have the full customer 360. And then also there is like item 360 for any retailer, and then doing an identity graph for any telecom company. All these use cases you see are eventually related to, or are because of the connected data, because there's a relationship between a customer A and customer B, and that relationship is important. And there is a relationship between the customer's likes and the customer dislikes, and then where does customer shop. And also then you can also do like advanced analytics, like if you already have a connected data, if you already have a very strong data, you can ask those questions to that data. You can analyze that data, like for like supply chain in Jaguar Land Rover. We did a supply chain use case where the supply chain planning accelerated from 3 weeks to 45 minutes, because now all the supply chain data is connected and is in graph, and as graph is so performant, you can just ask that question. You can write your GSQL query and get your data faster and quicker, and also is based because it is connected, you have more information. Then then again, like the fraud detection, our phones, right? Our phone can connect that, okay, like is this phone a fraud phone, or should I pick this up? Similarly in the banks, right? If this is a fraud transaction or is a valid transaction, everything is is better when you have basically a graph database. And then also in database machine learning is possible in the graph databases. Like, for example, you learn from your connected data. If you are continuously doing graph-based feature generation, and then you're training your system to make appropriate decisions. And so if you already have your data, and then you can do advanced analytics on top of it, and obviously you can train your AI or your system better by learning from the connected data. Then back to the problem, which I think is very interesting. We think customers are important, so just draw the customer 360 graph. And similarly for, as I said, right, patient, retail, your supply chain use cases. But also, I think it's really important to solve this data problem by using a graph and doing a 360 view of the data. So let's I just put this picture, and let's talk about a very, very easy use case or a story, right? Like, I go to a grocery store and there's no milk, right? What's an impact on me? I would just walk to another store and get milk. Maybe I waste like 4 or 5 minutes. And then look at the impact at the retailer. Excuse me. Yeah, look at the impact at the retailer. So the retailer, excuse me. Let's talk about a scenario where we walk into the milk store and there's no milk. So let's talk about what is the impact on us, or what's an impact on me if I'm walking into a milk store and trying to get milk, and the shelves are empty. Not much impact, right? I'll just walk into another store and get a bottle of milk. But what's the impact of the retailer? What's the impact about um, on the organization or on the business? The impact is huge. The impact is huge on the retail, because when you do not have a product your customers are looking for, there's a above and below the counter impact of problems like this in retail. So you have unhappy customers. Your customers would complain, so you would eventually lose your NPS score. Definitely return on investment loss, because you are using, there is a dollar value to it, and you would lose that value. And also people would complain on social media, so you lose your social media reputation if the customers were unhappy, or people might post a picture of an empty shelf in a store, and people would start going to another store, so you lose a customer or a new customer or an existing customer as well. But now somebody has to solve that particular problem, right? So you also have a productivity loss, because you eventually have to do a root cause analysis and see that why did this problem come at the first time. So a team of few people would sit down, look into some reports, look into some data, would analyze what happened, and would solve this problem that where in the whole supply chain system that something messed up, that they didn't have enough supply. So uh, so I just give an example in the retail, but this problem can come anywhere, like in finance. Imagine the impact of looking into the wrong data and or reports, or in DevOps, right? The IT guys or DevOps people are making decision looking at so much data every day. What if that data is not healthy? Same for AI. The data needs to be so healthy so that the your all MLAI algorithms are in place and can perform well and with full accuracy. Your data has to be important and needs to stay healthy for that. So I want to briefly talk about that when there are so many resources in place and we all know that data is so important, then why still these problems come in enterprise? So enterprise data is complex and it's a moving target. Data is never at, like at one place and in one state. Data is always changing. Data is always transformed. Data is always moving from some source to destination. And when data is moving from source to destination, in between it's taking multiple hops, right? So if you have your business operational data, you have some kind of streaming job and you moved it to a data lake, and then from data lake there's a transformation jobs happening on it, and it's on data warehouse. There's might be some AI analytics algorithm or some analytics jobs going on, and then you generate some kind of reports where people use these reports to make decisions. So all the more critical reports or critical data, right? But when data was on its journey, the problem can happen anywhere in the system and can ripple up in the system and can create problems in your system. And you, as a data owner or a person responsible for this whole system, want to have a 360 view of your data. You want to know that what's going on where in the organization, and where in your data pipelines, and what changes need to be done, or how quickly you can fix. So basically you're doing the impact analysis, that wherever this change is going to cause an impact. And you're also doing a root cause analysis, that okay, why at first place this problem happened and how I will solve it. So I think the answer lies in the connected data. If your data is siloed and if your information is not kept intact, if your relationships between your entities are not kept together, are not connected, then definitely you the decisions or the analytics on the AI on it will not be as accurate. So if you want to, same for any other system, same for data, if your data needs to be healthy, data needs to be intact, in place, and you want to have full trust on it, then graph is the way to go. And let's talk about what else you need if you are trying to do the 360 view of any of your data or your schema, right? So you basically need time travel, right? So sitting in today in 2022, I might need to know what happened in 2021 or what happened 10 years behind. So I want to just travel back in time. And also you would need graphical representation, right? Somebody who graphically can depict and show you how your data looked, how your data is connected, how your data is dependent on each other, and where in the system you see these problems. So basically you also need lineage, right? You want to see the downstream impact. If there is a data set X which is impacted, where else in the system it's going to make more impacts. And then events, right? If there are schema change events, there are some kind of events that are happening on the data, and you're tracking that data. And also you're generating some events, right? So you need to manage those events, and also some kind of scoring that you can put on the on your data, that okay, this data is healthy, this is not. So one of our product actually uses Tiger Graph, and this is Tiger Graph's in-house product, where we do the advanced analytics for data change impact and end-to-end data flow and systems. So it's an enterprise graph analytics UI application with visual monitoring, reporting, and exploration design for data operations, where data dependencies are tracked, monitored, and visualized, so that any stakeholder can have 360 view of the healthiness on the data pipelines. for any reports they are generating or any kind of dashboard. So in this screenshot here, I took from one of our products where it shows, okay, how healthy are the reports, how healthy are data sets, how healthy are the jobs. So it just puts that right scoring on top of it, that how healthy it is, how can you score. So basically to increase your confidence in your data. So that kind of ties back into my talk, right, where I think the graph is so important, and the how graph presents the information, or how it saves your information. It helps you answer those questions that are really important, right? You're basically on your complex data, you're trying to answer a trying to ask a complex question, and you'll only get a right answer if your data is kept in a graphical way on a graph database where all entities and their relationships are preserved. So I generally like to say that for when I say you do the 360 of your data, basically you graph the journey of your data when it's transferred, aggregated, transformed, processed, and analyzed by any applications and reporting tools. So in this screenshot I took, you can see that how some points are green, some are orange, some are red, right? So red is a clear indication that here in your data flow, here in your data pipeline, something's wrong. So that needs attention from a DevOps or an IT. You can immediately look at the red and see what's going on, do an immediate root cause analysis, and then fix it. So who all can benefit from it? Anybody who deals with data, anybody who wants its data to be healthy, anybody making decisions on the data. It can be a DBA, it can be an analyst, it can be a DevOps person, it can be somebody who's just looking into the data and making decisions. Yeah, so that pretty much concludes my talk. I think with the as I said, right, to graph or not to graph is not even a question. We all will graph, and we just have to look for that right use case, that opportunity where when to start. So I think if you guys are interested, I would really encourage you to go visit our site, www.tigergraph.com. Look at some amazing use cases we did with Graph, and how we solved problems for fraud and for supply chain and other use cases, patient 360, customer 360. So all that information is on the site. And if you are hiring, so if you have any referrals, or if you know anybody who would be interested, please feel free to ping me at binu.kohli@tigergraph.com. There's a career site, and there are jobs listed. You can also directly apply. And also I would, if you have any questions about the talk today, or you would like to connect or talk about Graph, or if you are a Graph enthusiast or wanting to see more products or more demos, I'm just an email away. So just send me an email at binu.kohli@tigergraph.com, and I would love to connect with you guys. And thank you so much for listening today. I'm myself so excited for the other talks we have in the session today. So yeah, so go have fun and enjoy your conference. Thank you so much for listening. Bye. Take care.